Before your engine is warm, oil is not just oil. It is the difference between metal parts sliding on a protective film or scraping through the harshest moment of the drive. Studies of engine tribology consistently point to cold startup as one of the most severe wear conditions because thick, cold oil can struggle to reach friction surfaces quickly. And here is the twist. 10W30 is not stronger than 5W30 once the engine is hot. In the SAE system, they are both 30-grade oils at operating temperature. The real fight is what happens before the engine warms up. By the end of this video, you'll know exactly when 5W30 makes sense, when 10W30 can still be correct, and why the wrong choice can give you more oil pressure but less protection. The answer is not brand loyalty, internet folklore, or my uncle used it for 300,000 miles. The correct oil starts with three things: the SAE viscosity grade, the engine design, and your climate. The W does not stand for weight. It stands for winter. The number before the W tells you how the oil behaves during cold cranking and cold pumping. The number after the W tells you the viscosity grade when the oil is hot, measured around engine operating temperature. SAE J300 is the standard that defines these viscosity grade limits. Think of viscosity as how stubborn a liquid is. Water runs fast. Cold honey fights you. Engine oil does the same thing. Cold oil gets thicker, hot oil gets thinner. The trick is making one oil that is not too thick on a cold start and not too thin when the engine is working hard. This is where SAE J300 matters. The winter rating is not guessed by pouring oil out of a bottle. It is based on controlled low-temperature tests, including cold cranking and pumpability. A 5W oil must meet its cold cranking limit at a lower temperature than a 10W oil. A 5W is tested at minus 30 degrees Celsius for cranking, while a 10WS is tested at minus 25 degrees Celsius. For pumping, 5W is tested at minus 35 degrees Celsius and 10WS at minus 30 degrees Celsius. So here is the clean comparison. 5W30 flows better in cold conditions than 10W30. But once both oils are fully hot, they must both behave as SAE30 oils. Not identical molecule for molecule, because brands formulate within a range, but they sit in the same SAE30 hot viscosity class. This is where many people get fooled. Thicker cold oil can create higher oil pressure because pressure is partly resistance to flow. But pressure alone is not lubrication. The engine needs enough pressure and enough flow to reach bearings, cam journals, timing components, lifters, and turbochargers. SAE research describes oil pressure as resistance to oil flow under pump action. At the same flow rate, higher viscosity gives higher pressure. Inside an engine, oil has two jobs that fight each other. It must be thin enough to move quickly and reduce pumping losses, but thick enough to maintain a separating film under load. Too thick can raise drag and delay flow. Too thin can reduce film thickness and hot oil pressure. The best oil is not the thickest oil. It is the viscosity the engine was designed around. Now add one more term: viscosity index. This tells you how much an oil's viscosity changes as temperature changes. A higher VI means the oil's viscosity curve is flatter. It thickens less in the cold and thins less when hot. The viscosity index is dimensionless and is commonly calculated using viscosity measurements at 40 degrees Celsius and 100 degrees Celsius under ASTM D2272 or ISO 2909 methods. Multigrade oils use base oils and viscosity modifiers to cover both cold and hot requirements. That is how an oil can act like a 5W in cold testing and still meet the SAE 30 hot grade range. But viscosity grade is not the whole oil. API, ILSAC, ACA, OEM approvals, additive chemistry, oxidation resistance, deposit control, and timing chain wear protection also matter. Use 5W30 when your owner's manual specifies it, when you see freezing or near freezing starts, when your vehicle is modern and built with tighter oil passages, or when the manual lists 5W30 as the preferred all-season option. It gives you the same SAE30 hot grade target, but better low-temperature cranking and pumpability than 10W30. Use 10W30 only when your manual allows it and your climate is warm enough for its cold start limits. In older engines designed around 10W30, in warm weather, or in equipment that operates mostly above freezing, 10W30 can be completely appropriate. The key phrase is when the manufacturer allows it. Many manuals include viscosity charts based on ambient temperature and use conditions. If the oil is too thick for the temperature and engine design, the starter works harder, the pump works harder, oil may take longer to reach critical components, and hydraulic systems like variable valve timing can respond poorly. High pressure on the gauge can look comforting, but excessive viscosity can still mean poor lubrication flow. Noria's lubrication guidance notes that viscosity that is too high can create greater pumping resistance and contribute to lack of lubrication in the system. If the oil is too thin for the engine, load, and temperature, you can see lower hot oil pressure, more consumption, more noise, and reduced oil film margin in bearings and cam contacts. That does not mean thin oils are bad. Modern low-viscosity oils can be excellent, but only in engines designed and validated for them. SAE literature on lower viscosity grades recognizes fuel economy benefits while noting that durability can suffer if high-temperature, high-shear viscosity is too low for the hardware. Now the big myth. An older engine automatically needs thicker oil. Not automatically. A high-mileage engine may have more bearing clearance, more oil consumption, or harder seals. In some cases, a slightly thicker hot viscosity, if allowed by the manual, can reduce consumption or improve hot idle pressure. But it is not a repair. If pressure is low because bearings are worn, thicker oil may hide symptoms while flow and cooling still suffer. A better first move is to use the correct viscosity with the correct specification. Check oil level regularly, fix leaks, and consider a high-mileage formulation if it meets the required grade and approvals. High-mileage oil is about formulation. Seal conditioners, detergents, anti-wear additives, not simply dumping thicker oil into every old engine. Here is the verdict. If your manual says 5W30, use 5W30. If your manual allows both 5W30 and 10W30, choose 5W30 for colder starts and 10W30 only in warmer conditions where the manual's temperature chart permits it. If your manual specifies 0W20, 5W20, 0W30, or another grade, do not upgrade to 10W30 because it sounds stronger. API guidance is simple. Vehicle requirements vary, so follow the manufacturer's SAE viscosity recommendation. The simplest rule is this. The first number is about starting cold. The second number is about staying protected hot. Between 5W30 and 10W30, the hot number is the same grade. The cold number is where 5W30 wins. So which one does your car actually need? The one printed in the manual, matched to your climate, with the right performance specification. For most vehicles that allow both, 5W30 is the safer, all-season choice, especially with cold starts. 10W30 is not obsolete, but it belongs where the engine and temperature charts say it belongs. Oil is not chosen by fear. It is chosen by engineering. Correct viscosity gives the pump something it can move, the bearings a film they can ride on, and the engine the protection it was designed to use.